Foldable, textured silicon wafers for flexible heterojunction solar cells. Researchers at the Chinese Academy of Sciences have successfully created foldable crystalline silicon (CC) wafers, known for their strong light harvesting capability, for use in flexible silicon heterojunction (HJT) solar cells. The scientists said HJT cell technology is ideal for making flexible solar cells, as it eliminates edge warping caused by inner stress during the firing process. The wafers were developed with blunting treatment, a technique commonly used to round a wafer's edges, in order to prevent chipping and cracking during processing. The researchers said that the treatment resulted in a transition of the fracture mechanism from intrinsic brittle cleavage fracture to shear banding with steps and cracks. The research team used 180M Zochralski N-type CC wafers, supplied by China-based Sichuan Yongsheng, to create textured wafers with a thickness of 60 m. 1 volume % alkali water solution at 80 C for 10 minutes to form microscale pyramids on the surfaces, it explained. All wafers were cleaned using a standard root cause analysis (RCA) process to remove organics and metal ions. Next, they underwent cleaning in 2.0% hydrofluoric acid water solution for 3 minutes to etch the surface oxide. The academics used the wafers to produce 2 HJT cells with thicknesses of 65 m and 55 m. The first cell had a power conversion efficiency of 23.31%, an open circuit voltage of 0.752 volts, short circuit density of 0.09 mA cm2, fill factor of 82.40%. The group then applied an anti-reflective coating based on magnesium fluoride, MgF2, on the cells and their efficiency was raised to 24.50%. Although this value was lower than that, 25.83% of a thick cell because it was affected by the inferior light harvesting ability of the thinner wafer. It was a remarkable efficiency compared with that of the current flexible solar cells fabricated from other cost-effective materials, the scientists said, noting that the use of a 60 m wafer could reduce production costs by approximately 29%. Overall, the flexible technology developed in this study reduced the levelized cost of energy by approximately 39%, 23%, at the solar cell, module, level. The academics presented the new manufacturing process in flexible solar cells based on foldable silicon wafers with blunted edges, which was recently published in Nature. Thank you for watching and make sure to subscribe for more videos.